Welcome back. In this lesson, we're going to be focusing on now instead of just expressions, now we're going to talk about equations. And the first thing is just talking about how to solve simple linear equations. So again, by solving, what it means is finding what value of the variable makes that equation true. To find that solution, what you're doing is you're using inverse operations to undo every operation you see to get the variable by itself. And again, this is a skill you've been doing for years. So inverse operations. So for example, if I have x plus 4 and I want to get the x by itself, I need to subtract 4 from both sides to get the x alone. And then negative 12 minus 4 more will give me a negative 16. 12b equals 18. So here, if I'm trying to get the b by itself, right now it's being multiplied by 12. So to undo that multiplication, I'm going to divide it off. So an 18 divided by 12 is going to give you 1.5. Now, two-step equations. So in two-step equations, now you have multiple things that you have to do. And so you really have to think carefully about the order of operations, okay? So order of operations, but if you think about undoing it, means you're doing them in the reverse order, okay? So for two-step equations, you're actually going to add or subtract first, and then multiply or divide, okay? So if I look at this one, what that means is I want to add the 1 over first to get 3x equals 15, then divide the 3 off to give me that x equals 5. Over here, it means I want to subtract the 1 first and then multiply both sides by 2 to undo the division to get the x equals 6. All right, now, sometimes you can clean up an equation first. So we've talked about one step and two step. Now what about cleaning it up? Well, when I say clean it up, what I mean is I would get rid of any distributing first, okay? So if you see a parenthesis like that, I would just do away and do the distributing first. So 2x plus 6 equals 14. So distribute the 2, and now everything that you have to work on is just like what you've done before. Now you can subtract the 6 and divide by 2 to get to your answer of 4. The other one, so there I can clean this up because the entire thing is being divided by 3. So because the entire thing is being divided by 3, to clean it up, I'm actually going to multiply by 3 first. Since the whole thing is a giant fraction, I'm going to clean up that fraction first. Now that I have that, now I can add the 2 over to finally get the x by itself. And x is going to equal 23. Now, even beyond that, then we can also have situations where the variable is on both sides, okay? When that's the case, I need to bring the variable together, okay? So in that first one, 2x plus 3 equals 4x minus 9. To bring the variable together, I'm going to subtract the 2x from both sides, because that'll completely get rid of it off of that side. And now they're together over there, okay, on the right-hand side. So again, that's what you do whenever you have the variable on both sides, is add or subtract it completely off of one side to get it solely on the other. And now again, the rest of this is skills that you've already done. Now I can add that 9 over and divide by 2 to get the x equals 6. All right, so in the next one, I do say have my variable on both sides, but there's something I can actually do first. The first thing I'm actually going to concern myself with is distributing that -2. All right, I always want to clean up before crossing the equal sign. So I'm going to clean this up to give me 3x plus 4 equals -2x plus 14. I'm going to distribute the -2, or that -2. Now I'm going to bring my sides together. So here, I think it's going to be easiest. Let's add a 2x to both sides, because it's going to cancel it off of that side. So that's going to give me 5x plus 4 equals 14. Now this is just like exactly what you've already been doing. Minus the 4. So 5x equals 10. Divide by 5 to get x is going to equal 2 in that case. So all of that is just review of basic solving skills. Now there are some situations that can arise, and I call these our special cases. All right? And they're special cases because the variable is going to cancel out. So let's see what I mean by that. So the first thing I notice in the left-hand one is there's a lot of cleaning up that can be done. For example, I can take 6x minus 2x, right? I can combine those like terms first to clean up that side of my equation. Over here, I can combine the 4 plus 1. 4 plus 1 is going to combine to give me a 5. So now that I have that, I see my variable on both sides. When the variable's on both sides, remember you add or subtract it off of one of the sides. So let's get rid of this 4x over here. However, if you notice, when I go to subtract it off, my variable is now gone. Okay, my variable completely canceled out of the equation. So that leaves a dilemma, okay? Because now there is no variable. I can't solve for the variable. So here what I notice is I'm left with a true statement, right? The variable canceled off and I was left with a true statement. So what that really means is no matter what x was, no matter what value x had, it was always going to lead to this solution, okay? This is always, always going to be true. So what that means is you have all real numbers as your solution. You could have put any value in for x and it would have solved the equation. It would have been true. Okay? So that's what happens when the variable cancels off and you have something true that you leave behind. Well, let's see the opposite situation. All right? So over here, 11 minus 7 is going to leave me with a 4. So I combined those like terms. Then 6x minus 3x is going to leave me a 3x. So I cleaned up both sides, and now I'm going to look at getting rid of one of my variables. I see it on both sides, so let's subtract it off. Well, just like last time, it canceled off of both sides simultaneously. So because it canceled off of both sides, now I'm left with something that's just inherently false, right? 4 can never equal 5. So what that means is it actually doesn't matter what value I put in for x. I was always going to get this nonsense statement. I was always going to get this false statement. So because of that, because I got something that's always false, that is going to give me no solution, okay? There's absolutely no solution that would make this true. So those are all of the little caveats dealing with linear equations. Thank you for brushing up on it with me. And again, once you're done filling in all of these notes, make sure that now you know that you're ready to go and do the associated worksheet.